let's solve these algebraic equations together. We have x plus y plus z to be equal to 17. We'll name this equation 1. We have x squared plus y squared plus z squared to be equal to 113. We'll name this equation 2. And we have root x plus root y plus root z to be equal to 7. We'll name this equation 3. We want to find the value of x, y, and z. Let's begin. So let's start up with equation 1. We have that x plus y plus z is equal to 17 from equation 1. So we can square both sides. Now let's recall when I have a plus b plus c all squared. This is equal to a squared plus b squared plus c squared plus 2ab plus 2bc plus 2ca. So this equation will become, we have x squared plus y squared plus z squared plus 2xy plus 2yz plus 2z times x to be equal to, we have 17 squared, which is 289. So we have x squared, y squared plus z squared. Now let's recall from equation 2, our x squared plus y squared plus z squared is equal to 113. So we'll be replacing this here to have this plus this plus this equal to this. So we have 113 plus 2xy plus 2yz plus 2zx to be equal to, we have 289. So from this equation, 2 is common here. So we have 113 plus, we'll factor out 2 from here to have xy plus yz plus zx to be equal to 289. So we'll have 2 times xy plus yz plus zx to be equal to 289 minus this crossing over will become 113. So we have 2 times xy plus yz plus zx to be equal to 289 minus this, we have 176. So we'll divide both sides by 2. So this cancel out. We have xy plus yz plus zx to be equal to 176 divided by this, we have 88. So we name this equation 4. So let's recall equation 3, where we have root x plus root y plus root z to be equal to 7. So when we square this, we'll expand this to have root x squared plus root y squared plus root z squared plus 2 times root xy plus 2 times root yz and plus 2 times root zx, which is equal to, we have 7 to the power of 2, this is 49. So resolving this will cancel out this, we have x plus this cancel this, we have y plus, we cancel out this, we have z plus, when we factor out these 2 here, we have 2 times root xy plus root yz plus root z x, and is equal to 49. Now let's record equation 2, where we have x. Equation 1, we have x plus y plus z to be equal to 17. So we'll be replacing this here. So our x plus y plus z is 17. We have 17 plus 2 times root xy plus root yz plus root zx is equal to, we have 49. So we have 2 times root xy root yz plus root z times x to be equal to 49 minus, we have 17 here. So this gives us 2 times root xy plus root yz plus root z times x to be equal to, we have 49 minus 17, which is 9 minus 7, 2. We have 32. So when we divide both sides by 2, this will cancel out this. We are left with root xy plus root y times z plus root z times x to be equal to 32 divided by 2. We have 16. So we name this equation 5. From this equation 5, we can square both sides. Squaring both sides, we have this. Then when we expand this, we have that we have root xy all squared plus root yz all squared plus root z times x all squared plus 2 times root xyz plus 2 times root, so this is x squared, this and this. We have xyz squared here plus 2 times root xyz all squared, which is equal to 16 to the power of 2. We have 2, 5, 6. So this implies that this cancel out this. We have xy plus we have yz plus z times x plus, when we factor out 2 from here, we have 2 times, we have root x squared yz plus we have root xy squared times z plus we have root xy times z squared is equal to 2, 5, 6. So this implies that we have xy plus yz plus zx. Now we still have common values here. We have y to be common here, and we have x to be common in all of them. So we have plus 2 root xyz times, from here when we factor xyz out, we'll be left with x. So we have root x plus root y plus root z all equal to 2, 5, 6. So when we recall equation 4, we have xy plus yz plus zy to be equal to 88. So we'll be replacing here over here. So our xy plus yz plus this is 88. So we have 88 plus plus we have 2 root xyz times root x plus root y plus root z be equal to 256. Or to recall equation 3, from equation 3 we have that root x plus root y plus root z is equal to 7. So this will be replacing here. We have 88. We have 88 plus we have 2 root xy z times this here is equal to 7 and is equal to 256. So we have 2 times 7, which is 14. Root xyz is equal to, we have 256 minus our 88 crossing over here, we have 88. So we have 14 root xyz is equal to 256 minus 88. We have 168. So we can divide this through by 14. This will cancel out here. We have root xyz to be equal to 168 divided by this. We have 12. So when we square both sides, we have that xyz is equal to the square root of 12 to the power of 2. We have 144. So we'll name this equation 6. Now let's remember the equations we've gotten. We have equation 1 where we have x plus y plus z to be equal to 17, and this is sum of roots. We have equation 4 where we have xy plus yz plus zx to be equal to 88, and this is sum of roots taking 2 at a time. And we also have equation 6 where we have xyz to be equal to 144, and this is product of roots. So we have product of roots. Now we'll be applying these 3 equations. We're taking the cubic equation whose variables are x, y, and z, where we have x yz to the power of t cube minus sum of roots, which is xyz, x plus y plus z times t squared, and plus sum of roots taking 2 at a time, which is xy plus yz plus zx times t minus the product of roots, all equal to 0. So we have t cube minus our sum of roots, so our sum of roots is 17, and sum of root taking 2 at a time is 88, and our product of root is 144. We have sum of root to be 17t, and we have t squared plus our product of sum of roots taking 2 at a time is 88 times t minus the product of root is 144. and is equal to 0. So we now have a cubic equation which we will resolve using the factorization method. Solving this cubic equation, we have t cubed minus, so breaking this minus 17 into 2, we can have minus 4t squared minus 13t squared. So this and this is equal to negative 17t squared. We have plus, we have 88 here, which can give us 52t plus 36t. And we have minus 144 is equal to 0. Factoring out from here, we have t squared, which is common from these two. We are left with t minus 4. We have minus, we can factor out 13 from here, 13t, and we are left with t minus 4. Plus, we can factor out 36 from here, and we are left with t minus 4, which is equal to 0. So we have a common factor here, t minus 4, t minus 4, and t minus 4. We factor it out, and we are left with t squared minus 13t plus 36, and is equal to 0. So it simply means that t minus 4 is equal to 0, and t squared minus 13t plus 36 is equal to 0. Solving this linear equation, we have that t is equal to 4. So we've gotten one value. So solving this quadratic equation, let's break this down. We have t squared, our 13, we can have minus 4t minus 9t plus 36 is equal to 0. So when we factor out t, we have t, we are left with t minus 4. When we factor out minus 9 from here, we are left with t minus 4, and is equal to 0. So we have a common value here, which is t minus 4, and we are left with t minus 9 is equal to 0. So our t is equal to 4, which is t2, and our t is equal to 9, which is t9. So we've gotten the three values that we are looking for. So let's verify using equation 1. Our x is equal to 4, our y is equal to 4, and our z is equal to 9. So we have 4 plus 4 plus 9, which is equal to 17. So when we add this up, we have 17 is equal to 17. So the left hand side equals the right hand side. Thank you for watching to the end of this video. Subscribe and hit the notification bell so you don't miss out on any of our solutions.